Cool. All right. Welcome all to a another Inference Gateway meeting, community meeting. Just as a reminder, we are part of the CNCF. We do follow the CNCF guidelines, so please be respectful to one another. Please remember that this is being recorded and uploaded to YouTube. Uh, so with that in mind, let's go ahead and take it away. We have some action items from last week. As always, we'll take a look at our uh, benchmarks, our weekly benchmarks. I believe they are. Uh, just basically gut checking, making sure that we do see that our K8's baseline is lower performance than our inference gateway for a prefill heavy. We'll take a look at decode heavy. I don't expect as much benefit, uh, but we still do see some, which is great. Means we haven't regressed. I think this might be needing updates. But regardless, again, we looking in the NT plot here. We do have better dashboards on the horizon. I saw some of those earlier this week, I think it was. So we can expect some updates there. So these are hopefully a little more readable using TPOT, TTFT, that kind of thing. Cool. So then some other action items mentioned. If you weren't here last week, Abdullah's proposal to move the EPP to the LLMD repository was shared. That is still the current plan of record, just figuring out logistics. And as part of that, we're proposing to move the BBR as well. Justification being that much of where the code is being contributed, specifically for the EPP, is happening in LLMD since they take a dependency on us as a library. So a lot of times that means there's going to be framework changes, and so we just wanted to move that all together. Again, just as review, APIs would hopefully remain here. We're discussing exactly what remains, how all this process will go. That's still in talks. And part of that was to reach out to the AI Gateway Working Group community because the BBR and what they are trying to do is somewhat similar. While we still do own the code, working groups can own code. We did want to make sure we were working with them. So got verbal sign off. I'm going to go ahead. It's been on my to-do list to write up a doc and basically say, this is the plan. This is what we think, and get sign off from everyone there. I have not reached out to the conformance working group. I'm not sure who was holding that action item, but
I think it was Abdullah.
okay. I'll follow up with him to make sure that is correct. So I'll assign that to me. I'm going to set an action item here for me to actually write the doc.
Mike raised a good question in chat, like where the APIs that are tied, pretty closely with EPP would live, like inference objective. Um, I don't, I think this is all pretty fluid, but I have assumed those would be more because they're so tightly coupled with EPP. Those may fit more closely, alongside it. Where I imagine this going, and I've been wrong, before, is that we would end up with an ecosystem, hopefully, of different endpoint pickers, and there may be different APIs to configure those different endpoint pickers. And the thing, if you're a gateway implementation, is the contract you have to connect to an endpoint picker or to connect to gateway API, whatever, is constant. But this needs more discussion.
Yeah.
I don't think, I don't think there's consensus in any group I've talked to about this or talked with about this. It's kind of just been, undecided from as far as I can tell anywhere. But that's my own personal bias.
So I It's a great question. There's not a solid answer, but from my perspective, the way we are moving with the EPP framework is to try to set, hopefully eventually we can set some sort of conformance test, and it's like this is what we found as we've developed this. And then, similar to gateway API, it's a little different because it would be, multi levels of conformance tests, but that's, kind of how inference gateway has been. So we have a current conformance test making sure it can communicate with a gateway properly. Well, this question of what is an EPP, what would make this an inference gateway, we've always been focused on multiplexion. So a lot of these APIs that are close to the EPP are part of that. So as we mature those, the idea would be, here's what we would expect from a conformant EPP to multiplex correctly to get these guarantees. Totally agreed that I think people will make different EPPs, whether that's forking from our framework or writing their own, because we are in Go. Some people might want to be in a different language, but still fulfill the XProc protocol. That's fair. Um, I do think though we would need some sort of consistency if it's saying, hey, if I deploy this image, I can use these CRDs. I would expect the same with a different XProc image. So that's kind of what I'm thinking. But again, very few. Cool. Chopping through the AIs. Cool. I need to write this one. Uh, Sweet. We went through the nightly doing this. Sorry, I'm going to do this before I forget. Awesome. I think that leads us to the top of our agenda. And we have a newcomer. I'd like to introduce Brent. He's part of a research group within Google. Really sharp guy. I enjoyed talking to him. We both like mountain biking, so he's really cool. But I would like to, yeah, kind of let him take it away. I'm not going to steal his thunder with regards to the proposal. I'm going to give you co-host Brent, so you should be able to present, and I will stop presenting and please take it away.
Okay, I appreciate that a lot. Full transparency, I'm still getting to my computer. I think you have a link to the doc.
I do.
So you could get that up while I am doing that. I think that'd probably help us with that.
No problem. I can do that.
But sort of in the meantime, I am up. I am awake. I have adrenal failure. Well, I have taken my steroids, adequately prepared. So a brief introduction. So I'm Brent, sort of a former, I guess, current adjunct professor at Utah, but importantly a research scientist in Google's systems research group. And so really what we're trying to do is, more sort of, longer term research. And this is, the first of hopefully many attempts to contribute to the LLMD community. I'm really interested, load balancing, flow control. I think lots of interesting issues here. So without taking too much longer, the topic here of this document is, there we go, I found myself. Vamping done. I am at my desk. Thank you for bearing with me, everyone. Yeah, so the topic here really is about making the endpoint picker token size aware. So, what is the motivation here? If we do some simple benchmarking where we send a batch of requests, all of the same size, look at the achieved latency. One of the things you can see is really, you hit a plateau, at least in the case of prefill. This is to be expected. Prefills, expected computational complexity is proportional to the number of tokens that you're processing. At the same time, there's only a finite number of SMs on a GPU. And so, sort of with this in mind, we've really created three PRs here. The first is pretty simple. So all of this was built on top of PR 2271, which is supporting token-based saturation detection. And so this provides a ledger that gives us a signal for tracking the number of tokens outstanding at an endpoint. I've been doing all my experiments in disaggregated prefill decode. When I ran it, I got a nil check. So the first one is just a bug fix for that PR. The second one is adding the token itself. It really just queries this ledger to get a token count, does scoring in the exact same sort of way as the load aware score does, but it uses tokens instead of requests. And then finally we have the final thing is this token ledger wasn't built to support disaggregated prefill decode. For better or worse, a lot of my experiments that I've been doing are in the context of disaggregated prefill decode. So I had to create a third patch here that makes the token load aware, or makes the token ledger work correctly in prefill and decode. And one of the things here is this, includes an additional hook for the first token, i.e., prefill complete, to make this ledger more accurate. Okay, so I should probably pause maybe from discussion here, but we can always go on and look at an evaluation.
No hands as far as I can tell.
That's great. So, I guess, Kellen, if you're willing to keep on owning the screen, we'll just, go through some of the, initial results. I think as an aside, I should probably find a way to, contribute some more of these benchmarks back. But, one of the first things I did was, come up with the scenario where this is expected to have the most benefit. So this is a new, extremely synthetic, not going to claim it's a realistic workload. But what we're having is we're having a mixture of very large requests and very small requests. And so this is, a small model. This is just Quinn3 0.6b. It's got a maximum token length of 32. So we're sending 32K requests and 1K requests. And one of the I think really interesting things here, and we're load balancing over 4 prefill replicas. We have 1 decode replica. Decode is effectively disabled in this by setting the answer length to 1. So we're really just concerning about load balancing over prefill, which is really where this token length aware thing is expected to have the best benefit. And so what we see here is, I think, interestingly enough, we actually get improved throughput. Sort of at first principles, you might expect that we would just get improved tail latency, which we get improved median and improved tail latency. But this is, really getting at some of the problems that are being solved by the flow controller. And so really what we see is, you hit problems where with the even just prefill engines alone, once I get too much load on a single replica, what happens is its throughput doesn't flatline, its throughput decreases. And so by better spreading the load in terms of tokens across the different replicas, we end up with higher throughput. So we get lower median latency, lower tail latency, higher throughput. Very synthetic workload, but at least in the scenario where we expect this to provide a good benefit, it provides a good benefit. Shared GPT workload doesn't have that significant difference in token sizes. So we don't expect that significant of a benefit, but we do see that the lines stay equal, and when they finally diverge at a high load, which is effectively this overload scenario that the token load aware score performs the best in terms of slightly higher throughput. Yeah, I think we're on to the a little bit further down now there. And so, latency is skyrocketing here. This is importantly an overload scenario where it's providing this better throughput. But it does overload scenarios, things that are real exist. And then finally, if we have a fixed token size workload, we expect the token load aware score to perform the same as the load aware score. And so we validated this case. This is in fact what does happen. Yeah, so I think that's really the quick rundown. Sort of went through that pretty quickly. I think if I was going to give a conclusion, this is a fairly simple, straightforward score. I think maybe not everyone is going to use it, but I think it's absolutely a configuration that should exist in the Gateway Inference engine. Yes, we finally have some discussion. Near.
Yeah, so just a basic question. I'm assuming that you compared with the default configuration of the 322, right? 3 for the prefix scorer, and then weight 2 for the load aware scorer, and the third one also with weight 2. So I'm assuming that this token load aware scorer was replacement for the regular load aware scorer.
Yeah, that's a great question, and this is sort of a sign of me still ramping up, getting involved in this community. The answer is no. I absolutely did not do that. I can follow up and do that, if that's deemed important. But really, this was about experimenting with it in isolation.
Just to be clear, this is pre-filled decode, so those weights are a little bit different. It's not the default 322 is for
right, yeah,
dense
it's
serving.
for it. Right,
yeah,
right,
so
right.
this is different.
Yeah. Okay, so I'm not sure if it's written in the doc or not, because first time I see it, but I will read it after the meeting. So I think it would be useful, not now, no need to discuss it now, but it would be useful like to specify clearly what was the configuration in each and every one of the runs, like what is the baseline and what is the configuration in the new score, just for to clarify and to help understanding. But other than that, yeah, looks good.
Okay, that sounds great. I think I can even just modify the pull request, and I can just add the Helm charts that I used, if that's probably best, I think.
Yeah, whatever you prefer. Like we can, just put the configuration to say this is the setup or the configuration of the test. This is control group. This is what I'm testing. And then we have, you're checking some, like you have an assumption that this will do better. So this is the configuration of the new version. And then it's clear for the reader what are we reading, like what are we comparing.
Yeah. So I'm using the new YAML configuration in the GAE. So I'll just add to the document the 3 different YAML files.
Perfect. Thanks.
Cool. Any other questions? Okay. Sweet. I think this is an interesting area to research a little bit more. I know PD is something that ourselves and LLMD are interested in, and is still a little wild westy. So cool to see some innovation there.
Yeah, I think if I was going to say one
ahead.
comment, the thing that's missing is my real understanding is that PD is probably most important for TPUs, which is a bit funny that I then didn't do these experiments on TPUs. But I think for future contributions, I'll probably try to have some TPU focus here.
Cool. That sounds good.
Um, Maybe another question that just came into my mind. So I know that in LLMD there is some work in progress to implement EPD, kind of the same in a very similar mechanism to how PD is implemented. Did you like think about, can we extend this score to more profiles? Like, can we extend the benchmark? If I tell you tomorrow that EPD is complete and is fully implemented, can we run the same? Like, just out of curiosity, not
That's
not
a
something very serious.
great question. Excuse my ignorance, but what is EPD?
Um, EPD is so E is another stage that happens before the
Ah,
prefill and decode. This is like E is stands for
Embedding. It's embedding.
embedding,
hmm, yes.
Or is
Yeah,
it
encoding,
encoder?
embedding, and I
Encoder.
think it's encoding. Yeah, encoding
Encoding.
that
Encoding. Yeah.
you can.
Encoding? Okay.
Yeah,
My bad. My bad.
yeah. So
yeah,
I think that's a great question. I've been very interested in models that are embedding bound. Especially tend to happen on CPUs, not GPUs. I think the answer to that is it's really about this ledger. So that's this abstraction here. The score is meant to largely be independent, and you need to have a ledger that lets you track the token counts in each stage. So one of the nice things about prefill, at least in the PD case, is when you get your first token, you have a signal that prefill is complete. Um, and I think this is more of a LLMD or VLLM thing. In order for the EPD to work best, you'd really want a signal that E is done and P has started. So
yeah. Okay.
That makes sense. My understanding, Brent, is this optimization is specifically for prefill, right? So you could, as long as your prefill profile is distinct, which it is in PD and I assume in EPD, then this should still benefit for prefill work specifically, right?
yeah,
Yeah. So then it should compose.
yeah. I think the only concern would be that if you're adding things that are in the E stage to your tracked expectation of being in the P stage, this could improve or impact accuracy.
Okay.
But so that's still where having a signal that E is complete. But I think if E embedding processing time, if that's fairly deterministic, there might, so like I said, straight out of the box, this might impact performance. But I would think that this is a useful first step. Maybe we'd want to extend something. But
Hmm.
I think you'd still want this as the starting point for whatever you build next.
Cool. Cool. I'm gonna pause one few seconds for any other questions. Okay. Moving along. I know Near had to drop. I might try to run. Well, we'll wait for him. Do we have any open items to discuss? I know there's some further discussion around the proposal to move. If anyone has any other questions, happy to field that right now. Try to buy Near a little bit of time. I have worked with him some on this proposal, but it is ultimately his, and I'd like to let him own it. Mike, please go ahead.
Hey. Yeah, I just kind of wanted to go on record that while I'm supportive in general of like the idea of moving the implementation of the EPP out of the project, because I think like that would mirror some of the stuff that we've done in Gateway API in terms of like having implementations separate from the spec. I have some really substantial concerns about the idea of moving some of the other like CRDs and APIs like inference objective and things like that that are somewhat tied to the EPP, and moving those out as well. My like macro concern there is basically two things. It's one, I think it risks substantially like degrading the value of having a common API if like GIE is just like this like small top level thing, and then all of the business logic is custom and separate and implemented differently for different implementations of it. I think that loses a lot of the shared value. And then also like kind of like touching on what Rob was saying earlier, I think that conformance no longer becomes the right word for it. If it is more of like a checklist of capabilities, I think that that's like a substantially different thing. And that's kind of like what we had seen with some of like the AI conformance effort over in like the Kubernetes AI conformance thing, where it's less of like testable implementations and making sure that like the CRD works and more of like this feature or capability is present. I think that's yeah, I just have like some um concerns about that in terms of like the spirit and value of a like shared implementation governed under Kubernetes and CNCF.
Yeah, I've thought about this a lot. I think what we're trying to, this project has certainly evolved over time. I'll say like in my very early designs, docs, whatever around this project, what I hoping to happen, what I hoped would happen, wow, was basically that we would build an ecosystem, really two ecosystems. You'd have an ecosystem of extensions, basically, and a tight contract between those extensions and a gateway controller that could just implement one contract and then gain access to an ecosystem of extensions. Um, what ended up happening in practice is there was one, maybe two. I think like AI Breaks or something else has an endpoint picker like thing as well. But at least in this context, we've all focused pretty heavily on the endpoint picker that's contained within this project. Um, and that so that's probably fine. It's worked out well. It's effective.
It was an
But
expedient way to get a workable proof of concept. Like I think
yeah,
that has been fine.
I hang on.
yeah,
I gotta get in here. One problem I'm seeing is that, and this I will pose a question to you all. Do we see inference serving as solved, including LLM, PD, EPD, whatever diffusion, etc.? I see that as not even close.
I would agree it's not even close.
yeah.
It's a field that's moving far too fast to consider solved.
Faux show. And so that's my thought too. So that is kind of the crux of the matter, in my opinion. We have to get closer to a research community. Inference is this weird thing where we're going the speed of light and we're asked to build like production services on it. So that is, to me, that's why I focused on the EPP, because we are going faster than any one person can control. So that was my thought with the framework is, uh I wasn't the only one that worked on it, but one of the things I was thinking is like, how the hell do I predict what is going to happen next month? And it's like, I can't. So then I need to make myself like agile on my feet. So that's
Yeah,
that
It's
was
much
part of
easier to
this.
talk
So
about stable APIs for something like L7 routing, where it's like it's a
exactly,
problem that we've understood for 15 years.
exactly,
yeah, and that's
exactly.
that's kind of Yeah, +1. And so that's kind of why I think the thing that Kube can do pretty well is define a contract for how do we, call out to this experimental thing or type of thing, and then let that experimental type of thing just go wild, basically, right? And so what I think is kind of the open question is, where does that experimental contract end? We know for sure that it includes like inference pool and the way to call out to, an endpoint picker. Does that also include something like inference objective, or is that really just the domain of endpoint picker innovation, and there's like another endpoint picker out there that wants something like that isn't inference objective, for example, like that? Yeah.
So, Mike, just to make sure, I thought I misheard you. Are you concerned that the APIs will leave, or are you concerned that they will stay and they should leave?
It is definitely not the latter. I
Okay.
think
So,
like what I'm concerned about is the combination of APIs leaving and also adding some expectation of conformance, which isn't implementing a common API. It's a feature checklist, and the APIs vary across multiple implementations. That's specifically my concern.
Yeah, I think so. Kellen, if you no, okay. So I think uh what conformance means here is the other side of the contract. Right now, our conformance is focused on, do gateway controllers call out to endpoint picker correctly, right? Like and so all our conformance tests are focused on gateway controllers. If we move endpoint picker out, you need the inverse of that, of, does something claiming to be an endpoint picker, accept the call out from a gateway controller, well, from a gateway implementation, and respond with what we'd expect. I think that's really, so you end up with conformance tests for the second half of the contract. I completely agree with you that just like having conformance mean, there's a checklist of things, but there's no test, there's no real teeth to it. It just gets really messy. And that actually leads to
It's
discussion
not just
around
messy for
inference of,
implementation, but I think it's messy for users too.
yeah,
It's like
yeah,
there's totally different ways to configure functionality across quote unquote three implementations of a spec. I think that at that
yep,
point it kind of ceases to become a spec and is just three implementations of a similar subject area.
yep, yeah,
so
100%. And so yeah. So I don't exactly know, inference pool is easy, quote unquote, easy to test the defined behavior for either side of the contract. Inference objective, it's harder for me to think about how you would write conformance tests for that behavior. And so that could also be a criteria for what fits. Like, if the thing that we're saying Kube is good at is defining these kinds of contracts, do we only keep APIs that have the characteristics that you can write clear conformance tests? Like, I feel like the worst possible thing is that you can have APIs where you can't write clear conformance tests, but you include an implementation in Kube, or you can have APIs that you can write clear conformance tests for. The intermediate bit of like, you can't do either, feels like it's probably not good for Kube, right? That's it.
So actually, I somewhat disagree with that. I think that like the intermediate bit, like maybe I'm getting this jumbled up in my head, but like the intermediate bit of like conformance and standardized implementations end at some point. Like we have prior art there with service mesh. Like that was a problem that was not solved by Kubernetes that
Yeah,
had independent ecosystem of implementations that did not adhere to a specific standard, even though they still covered very similar scope. And like there was healthy competition amongst them, amongst many different implementations for many years. I think it's kind of like narrowed down a little bit now, but at least for a while, there was a lot of competition there in terms of trying to get the right balance of functionality and UX and scope. So yeah, I think that I'm open to that possibility if like this is gateway the inference extension ends at some point and beyond that is just like out of scope, out of bounds, not tested. And that's something where like LLMD has full flexibility to iterate and figure out what is going to work within the scope of that project. I think that's actually okay. Um, I think what I would be more concerned about is like some like fuzzy expectation of like things should sort of kind of work
Sure.
somehow without standardization of the actual APIs. So, like I
Yeah,
want to avoid like the network policy case where
no, no.
you know like a tiny API and then all of this like massive scope in Cilium network policy and other specific things that are like you come to expect that functionality, but it differs wildly across implementations.
Yeah, and so I think I'm actually agreeing with you. But my
Okay.
interpretation of that, as I'm talking through this now, is that if I can't find a good way to test inference objective, it feels like that fuzzy area that we should leave for implementation specific. Like in this context, we're talking about LMD, but I hope and imagine that there are other like AI breaks or something out there that like turn this into an ecosystem instead of a single, like one of the things we've been constrained with right now inside the project is everything had to fit in a single endpoint picker. Whereas if you could have different endpoint pickers, that could free you up a lot too. That all optimize or focus on different things. So no, what I meant by not good for kube is I meant not good for Kubernetes branded API standardization. Not like obviously good for Kubernetes as an ecosystem. Like yes, we should go wild. Like yeah, service mesh is a great example of added a ton of value on top of Kubernetes without any kube standard APIs. And that's what I see as possible here. I mean, obviously, I'm saying there's still some standard APIs, but just yeah. Anyway, Colin, you've had a hand in it.
No, it's all good. I think these are fair points. And I will fully admit my bias is leaning towards I don't care. I gotta keep up with the tide. So I think it's fair to have this different perspective. Question is, so currently inference objective, anything that isn't inference pool, you know, bang equals inference pool. Uh, that's all alpha. Very intentionally because even inference objective is just a priority field right now. Like it's just a priority field. I have thoughts and plans and ideas of what it we could add, but I need to feel that out. So my question is it okay to leave it in inference gateway repo for now, the Kubernetes one, until we find some maturity? In a year from now, will we have better perspective and go, oh, okay, an EPP that implements LLM serving versus one that implements diffusion serving both have need for multiplexion and this user interface admin, but they're completely different. The way they handle things are completely different, and that is true. But that is, that to me, that's the paradigm shift of inference, is that there is so much context. It's L7 like brought to its conclusion, almost. So I'm of the mind that we can leave it in Kubernetes as an alpha. And if we even start to like, maybe we mark this in the API of it's like, here are some of the concerns. Should we ever go to V1, these concerns absolutely must be addressed, because I think that's valid. I get what you're saying, where it's like, if this API is based on some binary and that binary can mean anything, what does the API mean? Fair enough. Fair enough. But in this case, like I said, we're still very much unsolved. So it just like, my answer to you is, I don't know. Like, I don't even know what the API is going to look like when we're
Oh,
ready to go
absolutely.
V1.
Yeah, I
So
think that's totally fair. And I think like that's I think that you're asking the right question with like, is this something that a year from now we'll have a better idea of what common APIs across multiple implementations make sense to try to standardize? I think that that's reasonable. I think what I'm concerned about is a little bit of what we started to see, and I'll cite the like thing that Eric on my team came across working on implementation of GIE and Istio was like something that was implemented as an Envoy filter, but was not actually possible to configure in Envoy directly, and we needed to kind of go figure out how to do that and like PR that into Envoy to make that possible, even though it was already in conformance. So that's the kind of thing that I'm concerned about is that like having conformance basically running ahead of the actual implementation and experimentation. That's where I'm worried. If we're like we draw the line of we're not trying to do conformance because we don't know what the answer is yet. I think that's like a totally wide open, reasonable way to approach this problem if we are truly in that experimental phase and we're trying to we don't know what a good API looks like and we're trying to figure that out. I think like that's a reasonable space to be in at this time.
So I don't know if Kellen was first here or not. Okay. Yeah, I completely missed that there was something like that was a gap in conform. I was actually running through conformance and I saw we had like 8 conformant implementations and I was surprised and happy with that. But I like if there's some hacks in Envoy that are needed or I don't know. I haven't actually like dug into that, but maybe like I know Near should talk soon, so maybe we can chat on Slack or something like about that. But that seems not expected. Um,
so just, we got 3 minutes. Um, just to, wrap this up with a bow, if we can't, as much as we can, uh, are we okay with APIs staying here? I think that's, Mike, that's fair. I don't want to I have no intention to write conformance tests on the alpha APIs, because again, I don't know what their final state will be. And so I think that's something, let's consider an action item to address, make sure that we address these concerns when V1 happens. Is that a fair moving forward stepping stone?
Yeah, I think I think there's the question of like promoting to V1, but there's also the question of like, is it the right time to start introducing new things in like a V1 alpha state, like within this project, if we are really that unclear on whether those are appropriate common APIs or if we're still like in a truly experimental phase. And I
So
did drop
you're
the mic.
questioning if we introduce V1 alpha one? Okay, I, we have, where else, what's the base minimum we can have for experimentation? To me, that was V1 alpha one.
Yeah, so I think it's a question of like it's a question of where those APIs live. If we're truly in that experimental like track of we just want to move as fast as possible and figure out in a project like LMD, um, that like that's where we want that flexibility to move as fast as possible and kind of figure out
Mhm.
what works before we try to like standardize it, then maybe implementing those APIs in LMD first is fine and good. What I was specifically worried about is trying to standardize and apply conformance and expectations
Sure.
to a thing that we haven't figured out yet.
I
So
have a question, Kellen. Did you say that we shouldn't have uh, conformance tests for alpha APIs. I guess from my concern is that yes, we'll stay quick with the trends. It'll be experimental, and that's great. But if we arrive at a V1 or something, it might be that because we don't have conformance tests, it actually doesn't work for most people to implement or support. Even though it's great, we've kept up with the trends, we might get to a point where this isn't actually feasible for anyone. V1, it's great, but it works for only those who built it, but not
Sure.
really anyone else to adopt. So we really have no sense of how useful this resource is, even though it covers the broad use cases that we are, observing.
So I'm proposing things that I think could help, mature these APIs.
Sure.
My initial understanding was that we wanted to leave them in the repo, but it sounds like that might be flipping, and we actually want to pull them, which is fine too. I'm fine with that. I know that the concern is that this API would appear to be abandonware, and I really don't feel that that's the case. It is the goal, was to be similar to Gateway API, but I think if you talk to anybody that's involved in inference at all, and you say, "Yeah, we had to move closer to research and experimentation because it moves fast," I think everyone would go, "Yeah, that makes sense," and because we all feel the same way. So I'm hoping that can combat that. The intent isn't to abandon this; it's just to streamline processes so we can move quickly and then get that information and do what Coog does best, and lock it down, stabilize it, make it production ready and hardened so that we get paged less. That's my thought. But again, open to continuing this conversation. I think we are over. We stole a minute of Nir's time. Let's continue this on Slack. Nir, let me give you co-host, and why don't you take it away?
Yeah, thanks. So not sure who noticed, but I had to drop because I had alarms, so hopefully no alarms again. And with that said, so this is the new proposal that we've been working on for a while. So this is something that Maroon was extremely active here in the idea of the design principles. Kellen was also involved in contributing. So basically, this proposal suggests to change the way that we treat scorers, and specifically not only the scorers, but the scheduler configuration. And instead of doing that statically at startup, we want to be able to adapt to changing traffic patterns. So basically, as of today, if I'll try to narrow down the scope, and hopefully we can get a chance to go over doc over all of it. But basically, if we look at the scorers, so there are two categories of scorers, and we also have today each scorer should declare its scorer category. So we have the affinity-based scorers, which tends to each scorer from this category tends to be sticky. So we can see in this example the prefix cache scorer and these kinds of things. And then we have the distribution scores, which their goal is to spread the load across the endpoints. So for example, we have the load aware scorer, which tries to spread the load. And this proposal is trying to bring in adaptive routing design that dynamically adjusts the weights based on the scorer's category. So we try to give a budget for every category and then split the weights between those category based on at this initial proof of concept that we've implemented. This is based on the ratio that was configured in the initial startup. Like if you define that you have two scorers, each of them with the same weight, that means that after the budget is assigned to that category, each of them will get half of the weight from the budget. So basically, the intention is to do that with no per request computation, no changes to the request execution path, to be deterministic, and to be asynchronous. there is the second suggestion here about burst and toggling between pickers, but I'll skip this for now because I want to focus on the scorers. So basically, we have here two concepts at a very, very high level. One concept is the new async detector. That is just a separate Go routine that runs asynchronously from the requests and calculates some signal. And in this specific case, the signal that we are looking into is the imbalance of the pool. So from one hand, imbalance of the pool, it looks more or less on the same metrics that the saturation is looking at, the saturation detection. But on the other hand, the semantics is different. So you can think about, like, for example, if the pool is fully saturated, like all the endpoints are like reached their limit. That doesn't mean that the pool is imbalanced because all the endpoints in the pool, they serve more or less the same. So they are in perfect balance, but they are saturated. On the other hand, if we have like, I don't know, a pool of 16 endpoints, two of them are serving all the requests and 14 endpoints are sitting idle, that means that we have here an imbalance in the pool and we need to somehow spread the load to the idle pods. So basically the async detector is the component that is responsible for calculating the signal. And in our case, that's the imbalance signal. And then we have the adaptive configurator that consumes that signal and translate that into scheduler reconfiguration at runtime. So we have here a section that describes the async detector. This is more or less what I just described. There are a few principles that we try to follow to optimize it, like signal smoothing. Like every cycle that we calculate the signal, we smooth to make sure that there are no, flip-flops and these kinds of things. We also follow the principle of once we change a mode, we should stick with that mode at least for a few cycles. That is very important for signals that are like Boolean, true, false. And we also try to do asymmetric thresholds for entering and exiting a state, again, for Boolean signals and these things. We don't want flip-flop. So this helps with that. Now, more specifically, the async detector, the first of async detectors, so potentially there could be a lot of them, is the one that detects imbalance. In the first version, that was a reactive imbalance detector, not predictive. And that was implemented based on statistics and more specifically on normalized coefficient of variation across the endpoints. We do the normalization to make sure that we can adapt to pool size changes and that the output is bound to this predefined range of a signal between 0 and 1. And then the adaptive configurator consumes it, calculates the budget for each category or family of scorers, and splits the weights between them. I'll skip the burst detector. We try to do initial benchmarks. I'll run very quickly on it because I have 2 minutes. So in the first benchmark, this was the one that we thought would show most the value. So we created a hotspot with a hot KV cache. We did that by running one concurrent request at a given time for 5 minutes with a long shared prefix that was sent always to the same endpoint because the first endpoint that got it was scored higher in the next requests. And then slowly we try to increase the number of concurrent requests. And we see that in all important metrics, the adaptive, which is the blue one, performs much better than the static configuration, the default configuration of EPP. So we can see here throughput much higher, TTFT mean is much better, ITL much better, and request latency is much better. Then we also repeated the LLMD intelligent routing benchmark. We have here the link. we saw some slight improvements or comparable performance, and depends on which metric we're looking at. But basically, we see improvement in the one that we expected, the hotspot, and comparable results in the second one. Yes, Kellen.
Yeah, just to call it out. So one of the control group runs did have failures. I did 3 runs of each. I didn't want to rerun anything because I didn't want to, you know, taint the data with my bias. It is possible that that was erroneous, but you know, the data is the data. So the all successful runs did see very, very similar performance, but that is cool because in theory that means that our affinity scores were equally weighted. In this case, we only had one, but our imbalance scores were equally weighted, and we had a few. We still want to run benchmarks to see if we can add an additional scorer equally weighted, and if that will hold. That would allow us to add arbitrary scores and have this still work. So that's what I think would be really compelling.
Yeah, and just to make sure that it is clear, this is not yet optimized. Like, we know that, for example, in LLMD and also in APP, that took a while to tune the configuration to reach its optimal performance. So we know that there is also additional work to tune the configuration of the adaptive setup. This is just initial configuration, and it already shows value. So I'm pretty sure that we can show a much higher value than we currently see, but this is already, a great proof of seeing the value. Like, we tried it with 2 different traffic patterns, and in each of them, it was at least as good as the static configuration, while in the most, let's say the first one, it was much better. Yeah, so I'll stop here. We're out of time, but please add your comments on the doc, add your thoughts. We're happy to collaborate and hear more ideas.
Cool. Thanks all. We are at time. We'll see you next week.
Bye-bye.